So I want to show you a little bit more about this whole vertex form thing again before we go on too much further. You might remember that vertex form for a quadratic equation is when it looks like this. So there's usually some number out in front. There's an x or an x minus or plus something inside parentheses that are squared. And then there's usually something out the back door here over like this. And this is called vertex form. And I'm going to show you a little bit more about that, remind you of some things, and then kind of tell you why we do this stuff a bit. So first, let me take a look over here. This equation is in vertex form, and you might remember from yesterday that the minus sign, for instance, that all it does is kind of flip the thing over. It means that everything is going to get multiplied by -2, and so it sends everything in negative. The x minus 6, what happened here was this minus 6 told you that the whole parabola got shifted to the right 6. Now, what do I mean shifted to the right? Well, if I start with kind of the original parabola right there, you'll notice that its vertex, the bottom of it, is right at 0, 0. Okay, and then if I put a 2 out in front, it stretches it up a little bit. So now it's kind of the same shape as this one, but this one is shifted to the right 6 and up 2. And what we noticed was this. With this one, if you wanted to make this part of this equation 0 so that you get the lowest possible value, you'd put a 0 in for x. But if you wanted to make this part of this equation 0, you couldn't put a 0 in for x because then you get 36 inside this blue part when you squared -6. That's not the lowest possible number you get. If you put 6 in, though, 6 minus 6 is 0, and then when you square it, you get 0. So the way we pointed out was this. Whatever you want to put in here to make it bottom out, that's going to be the x-coordinate for where it gets the lowest possible point. So if I put a 0 in for x here, then this equation bottoms out right here. Now, this becomes 0. Multiplying it by 2 stays 0, but then adding 2 basically bumps it up 2. So when you look at this equation right here, you can see that it's been bumped to the right 6 and up 2, even if you don't look at the graph. Okay, so I'm going to do this. I'm going to shift this way over here, get it out of the way. I'm going to type in a new equation. I'm going to ask you, what do you think's happening with this? Okay, so based on what you know, how do you think this thing is shifted left to right and up and down? And is it stretched or not? That kind of thing. So we're going to be asking that question. And I'm not going to worry about taking the time to put this thing into Edpuzzle so you can answer questions there. I'm just going to let you stop and think about that for a bit. You can pause the video if you want. Well, now I'm going to bring this thing back, and we'll see if your prediction was right. Okay, this one is the purple one. And I noticed that from 0, 0, it looks like it's been shifted to the left 4. And it's been shifted down 5. Well, if you look in here, the thing that will bottom out that highlighted part is putting a -4 in. That's the number you'd put in to get the lowest possible value. And so that confirms that it got shifted left 4. And then out the back door here, this -5 means it got shifted down 5. So we're going to do an exercise like that again. Let me just turn these off here so they're not distracting to you. And then we'll type in another one. Y equals -2x minus 1 squared plus 6. Okay, so what do you think happened with this parabola? Okay. So you might be predicting that it got shifted to the left 1. Some people make a mistake on that. They say the -1 means it got shifted to the left 1. And it's actually the opposite of that. Think of it this way. Whatever you put in here, you're trying to get the number that would get the lowest possible value here to bottom it out, to get the vertex. And you'd have to put a 1 in right here for x in order for x minus 1 squared to be 0. Okay, so if you said it got shifted to the right 1, you're correct. And then the plus 6, as you might predict, bumps it up 6. What did the -2 do? Well, the 2 stretched it. It was bigger than just the plain x squared like this one. The 2 stretched it more, but then the negative flipped it over. So it ought to be shifted right 1, up 6, flipped over, and stretched by 2. And sure enough, there it is. Right 1, up 6, flipped over, and instead of dropping down 1 in the first step over from the vertex, it dropped down 2. Okay? So that gives you a bit of a picture of what's happening. Okay, so you've seen a little bit about how the parabolas actually work, how they got shifted left and right, up and down, and flipped over and stretched and that kind of thing. And we're going to do some practice with that here soon. But the question still comes up, why would you switch from standard form to vertex form? That just seems kind of crazy. Well, I'm going to show you one example. I'm not going to ask you to be doing these yet. We'll do them later. But I wanted you to kind of see what's going on, just because it's nice to sometimes have some context for this stuff. So I've rebuilt our graph here in Desmos. You can see it's zoomed a little bit differently now. And what I've got is the equation for a missile that's been fired upward. And here's kind of the normal way you would see an equation for that kind of thing. T stands for the amount of time in seconds. And then I'm not expecting you to know this stuff yet or learn it right now or anything, but if you knew that you had fired the thing up at 80 feet per second, straight up, then you'd have an 80 right here, positive 80. If you fired it down, it would be a negative 80, but it's considered bad form to fire your missiles down unless you're in an airplane. The plus 20 means that it was standing on top of a 20-meter platform of some kind. So if it was only 10 meters, that'd be a 10 there. And then the minus 5 has to do with gravity. That number would be different if you were someplace other than the surface of the Earth. Surface of the moon would be less, and the surface of Jupiter would be more. So there's the equation in standard form for this missile fired in the air. But it's just kind of this generic equation. It's kind of hard to tell what's going on. So if I knew how to change this standard form equation into vertex form, and again, we've learned a little bit about that, but you didn't know quite how to handle the number out front here. We'll do that more later. But if I knew how to do that, then I could graph it this way, and this tells me a lot of information even without looking at the graph. But here let me show you how. Okay? Notice that this thing right here tells me that the graph is shifted 8 this way. Okay? Notice that it's shifted 8 this way, and then it's up 340. You can see that right here, and you can see it at the vertex there. Okay? So this equation gives me a lot of information. It took 8 seconds to get all the way to its maximum height. Okay? And at its maximum height, it was 340 meters in the air. So you can tell that information just looking at the equation. You can tell just looking at it. Okay? So this tells me not only how long it took to get to the maximum height, but also what was that maximum height. Now, you can't tell from the equation. We'll learn later how to do this. You can also tell that it took a little bit over 16 seconds to get back to the ground. Okay? So there's other information there, but that's one way that you could use your knowledge of how to change an equation from standard form to vertex form, to how to put that to good use. Okay, so last thing I want to do is show you what we're going to do with this. This is going to be an assignment on Delta Math, and all it's going to do is show you a parabola, and then it's going to ask you to tell me which is the best equation for this. Okay, so it's got 4 equations down below. Which one is the best one? Okay, well, I notice the thing is facing up. Okay, so it better have a positive number out in front here, but they all do, so that didn't help me much. Okay, I noticed that it's shifted to the left 6. Okay, so that narrows it down. It can't be that one and it can't be that one because those are both shifted right 6. Okay, so it's one of these two, one of the top 2 here. Which one? Well, it's also shifted down 1, and this is the only one that indicates that it's shifted down 1 and left 6. So there we go. Left 6, down 1. Submit answer. See what we get. Okay, let's do another one. Okay, so this one, it's upside down. Okay, so that tells me that whatever equation I'm going to have, it better have a negative out front here. Okay, a little trouble. Okay, so yeah, they've all got negatives. That didn't help much. But I noticed that this one is also shifted to the looks like it's left 6 and down 3. So which one is shifted left 6 and down 3? Well, These two are shifted right 6. That can't be that one. Both of these are left 6, but this is the only left 6 that's also down 3. Okay, good. That one's shifted right 6. Okay, and up 2. Okay, well, right 6 and up 2, both of these two are shifted right 6 and up 2. So which one is it? Well, it's also pointing up, which means the number here has to be positive. Okay, so it's got to be that one. Okay. That's the same problem. So that one is shifted to the right 2 and up 4. So let's look and see what we got here. Right 2 and up 4. Here's one that's right 2 and up 4. And here's one that's right 2 and up 4. So it looks like it's going to come down to whether it's pointing up or down. This one's pointing up, so it's going to have to be one with a positive number right here. Okay. So that's the kind of stuff you're going to be doing here on this next assignment. And I just wanted to give you a bit of a preview about why you would change something into vertex form if you had it in standard form. Okay, so that's going to do it for now.